This video is on using the quadratic formula and also identifying solutions using the discriminant. So we'll start with some examples to solve by using the quadratic formula, and you should have seen it before if you watched my first video or somewhere else in the past. But the quadratic formula, remember, is used just as kind of a quick refresher. I'll write it here on the side. To solve equations of the form of ax squared plus bx plus c equals 0, where a, b, and c are constants, x is a variable. And then it's a way of solving for x for this type of equation in standard form. So you have to have the ax squared plus bx plus c equal to 0, one side equal to 0, before you can use it. The formula itself, right, is that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's really what the quadratic formula is. You want to use it when you have an equation in standard form. If you don't have the standard form, right, it has to be quadratic, highest power is 2. You don't have standard form, you got to get it in the standard form first. You might move some terms around. So taking a look at this first one here, if I have x squared plus 5x equals 6, what I'm going to do is I'm going to subtract 6 from each side first so I can get the standard form, right? One side has to be 0. If I subtract 6 from each side, I end up with x squared plus 5x minus 6 equals 0. Now, if you can solve this by factoring, typically you would, but if I tell you to use the quadratic formula, you have to use the method I'm telling you to use to get credit. So even though this might be factorable, we're going to use the quadratic formula to solve it. We have the standard form. Make sure you recognize it's x equals whatever the variable equals. And when we say negative b plus or minus the square root of b squared minus 4ac all over 2a, remember a, b, and c come from the coefficients here. So in our case, a is equal to coefficient of the x squared, which is 1. B is equal to the coefficient of the middle term, which is positive 5. And c is equal to the coefficient, or the constant, the last term, which is negative 6. And so now we're ready to substitute in. So we have x equals negative b, so it's negative 5 plus or minus the square root of b squared, so b is 5, so 5 squared, minus 4 times a is 1, times c, which is negative 6. Make sure you have the correct sign there. This is all over 2 times a, so it's 2 times 1. Make sure you have it all over that, not just the radical part. So this gives us x equals, and we're just going to simplify this. We got negative 5 plus or minus the square root of 5 squared would be 25. A negative 4 times a positive 1 times a negative 6. So a negative times a negative will make this a positive. 4 times 1 times 6 is 24. This is all over 2 times 1, which is 2. So we get x equals negative 5 plus or minus the square root of 49 all over 2. And when I do this, you evaluate the square root of 49 if you can. In this case, this will give us, x equals negative 5 plus or minus the square root of 49 is 7 over 2. And negative 5 and 7 are like terms, but you can't combine them right away. Remember, this gives you two answers. Right, x equals negative 5 plus 7 over 2, and x equals negative 5 minus 7 over 2. So negative 5 plus 7, that would be 2 over 2, which equals 1. Here, negative 5 minus 7 is negative 12 over 2, which equals negative 6. And we have two answers, right? The two answers are negative 6 and 1. I'm writing it in the solution set here. But these are the answers that make the original equation true. Right, that's what you found. Now, if you tried to solve this by factoring, you still would have to get in the standard form first, but then once you had this, if you factored this, you would have gotten x plus 6 times x minus 1 equals 0, and then solving those, you would have gotten negative 6 and 1. And that'd be okay, except for if I ask you to solve using a certain method, you have to use the method so I know that you understand it. But realize these are two real solutions, right? And they're whole number values, they're rational values too, but because of this being a perfect square, that's why these came out to whole number values. These coming out to, well, I shouldn't say whole number, but integer values. The reason these come out to integer values shows you that you originally could have factored it. Let's take a look at another one. If I said I had negative 25x squared equals 10x plus 1. Right, and again, the directions are solved using the quadratic formula. To solve by using the quadratic formula, the first thing you want to do is get one side equal to 0, get that standard form. So in our case, the easiest way to get one side equal to 0 is really to add the 25x squared over to the other side. You could move the 10x and the 1 over and still get the same answer, but the process might look a little different. So I add 25x squared to each side, and I end up with 0 is equal to, we have 25x squared plus 10x, because it's a positive 10x, plus 1. You make sure you want to write it in descending order. And we want to use the quadratic formula. In our case, a is equal to 25, b is equal to the middle coefficient, which is 10, and c is equal to 1. Now, if you'd solve this differently for 0 on the right side, these would all be negative values, but it would come out to the same answer in the end. So let's take a look at the quadratic formula. So remember the formula, right, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm writing it quickly here. You should be able to write it quickly for yourself. It is something you need to memorize. And you get x equals negative b would be negative 10 plus or minus the square root of b squared, so that's of 10 squared, minus 4 times a, which is 25, times c, which is 1. And that's all over 2 times a, so it's all over 2 times 25. All right, and then we'll simplify this, and I'll just bring it up here so it's easier to see. So this will equal, all right, so this gives us x equals negative 10 plus or minus, make sure you know what x equals, right? It's the x value solution. Negative 10 plus or minus the square root of 10 squared is 100, minus 4 times 25 times 1, well, it's minus 100. All over 2 times 25 is all over 50. And we have x equals negative 10 plus or minus the square root of 100 minus 100. Well, that's the square root of 0 all over 50. Well, what's the square root of 0? Well, that's just 0. So we have negative 10 plus or minus 0 all over 50. Now, you could combine these. It's negative 10 plus 0 over 50, and then you'd also have negative 10 minus 0 over 50. Normally, we'd say it's two answers, but if you're adding 0 or subtracting 0, that negative 10 still just stays negative 10. So this is actually equal to just one answer. It's equal to just negative 10 over 50, because if you were to split this up, you'd get negative 10 over 50 and negative 10 over 50, which is the same answer. So you have negative 10 over 50. Because we're just adding or subtracting 0 to it, any other number, you can't just write it as one answer like this. And this reduces to negative 1/5, right? Divide both numerator and denominator by 10. So it's x equals negative 1/5. So it's one solution. It's real. It's a real number, right? There's no imaginary piece to it. But the answer is just one real, what we call repeated solution or repeated root. The reason we call it repeated is because, right, it really would have come up twice. Negative 10 plus 0 over 50, negative 10 minus 0 over 50, but it'd be negative 10 over 50 either way. So there's one answer, negative 1/5, but we call it one repeated real solution here. This can only happen, though, it happens because the part under the radical here, right, actually became 0. That's the only way you can get a 0 here that you're adding on, is if the part under the radical became 0, the b squared minus 4ac. Whereas in the previous problem, the part under the radical came out to a real number that's positive, right? So that's how you got that's how you got real number answers here. Keeping in mind, though, that, you know, this was the square root of 49, came out to a perfect square as well. It won't always be a perfect square, but it can be. And then let's take a look at just one more here. Sometimes people get thrown off by this, so I want to make sure that you understand how to use this. If I said I had again, the directions are solved using the quadratic formula. We have x squared over 2 minus 2/3 x plus 5/6 equals 0. So we have standard form. We have 0 on one side, which is good. The fractions might throw you off. Now, you could use the fractions in the quadratic formula, but it becomes really messy. So one of the things that we do to get rid of the fractions is, you know, when you're solving an equation with fractions, the first thing you typically do is you want to clear fractions by multiplying by the LCD. So what's the LCD in this case? Well, 2, 3, and 6, the least common denominator, is 6, and you multiply 6 to every term, right? So I had 6 times x squared over 2 minus 6 times 2/3 x and plus 6 times 5/6 is equal to really 6 times 0. It'll be 0, but you should still show it because that's what keeps it balanced. You're doing it to every term on both sides. And now we simplify this. So 6 divided by 2 will give me 3. So we have 3x squared minus 6 divided by 3 will give me 2. So negative 2 times 2x is negative 4x. Positive 6 divided by 6 will just cancel to a 1. 1 times 5 is just positive 5. And this equals 6 times 0, which is 0. So we're going to use the quadratic formula on this. You could have used it on this. You'll get the same answer, but you'll get complex fractions. It'll be a little harder to work with. So if you clear the fractions first and then work with it, it'll be easier to evaluate the formula. So remember the formula. For the quadratic formula, we got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's what we're going to use to substitute in. So we have x equals, now I'm not going to write a, b, and c this time, but you should be able to identify them from the problem. So a is 3, right? B is the negative 4, and c is the 5. So when I do this, negative b, it's a negative 4. Be very careful here, right? So this whole thing is b, is the negative 4. So when we substitute in, it's negative in front because of the negative sign from the formula, and b, which is negative 4. Plus or minus the square root of, maybe I'll write them just, I know I wasn't going to, but just so you can see it. Alright, so plus or minus the square root of b squared, so of negative 4 squared, make sure you have parentheses around it because it means something else if you don't, right? So the whole b is getting squared, so negative 4 squared minus 4 times 3 times 5. It's all over 2 times 3. And then we get x is equal to negative 4. Negative times negative makes that a positive. Make sure you make that a positive. So you get 4 plus or minus the square root of negative 4, the quantity squared, and negative squared makes that a positive 16. Negative 4 times 3 times 5. 4 times 3 is 12 times 5, so it will be negative 60. All over 2 times 3, which gives me 6. And so I have x equals 4 plus or minus the square root of 16 minus 60. Well, that's going to be negative, and that's okay. 16 minus 60 is 44 all over 6. And if you're looking at this here, we want to simplify as much as possible. So the square root of a negative, you know you can factor out on I, right? Because the imaginary constant is equal to the square root of negative 1. So we have 4 plus or minus I square root of 44. It's not a perfect square, but it has a perfect square factor and a non-perfect square factor. The highest perfect square factor it has is 4. The non-perfect square would be 11. This is all over 6. And you look with 4 plus or minus I square root of 4. Square root of 4 is 2, so we'll write that as 2i square root of 11 all over 6. Now, you could leave it like this, but this does reduce. It does, you know, there's two answers here. And there's two ways you could do it. We could factor out, noticing we can factor a 2 out of here. We get 2 times, factoring 2 out of the 4 will give me 2 plus or minus, factoring a 2 out of the 2i radical 11 will give me I radical 11 all over 6. And then this 2 and 6 will cancel to, you know, 1/3 really. So I end up with 2 plus or minus I radical 11 all over 3. Which is two answers. And that's okay. If you didn't like simplifying like that, another way you can simplify this is say that you have, you know, this 4 over 6 plus or minus 2i radical 11 over 6, and then simplify each of these individually, meaning 4 over 6 simplifies to 2/3 plus or minus 2 over 6 simplifies here to 1/3. So you have I square root of 11 over 3, and then you can combine them back and you can get back to here. So the same answer, it's a different way to simplify, but there's two answers, right? It's 2 plus I radical 11 over 3 and 2 minus I radical 11 all over 3. So two answers here. Important to understand you have two answers. The answers came out to imaginary solutions. The reason they came out imaginary is that this part under the radical had a negative in it, meaning it was less than 0. So if you're doing the quadratic formula and you get a piece that's negative under the radical, right, meaning this b squared minus 4ac comes out to a negative, you're going to get imaginary numbers, so you get complex solutions. And there'll always be two of them because of the plus or minus. So, this leads us to talking about what we call the discriminant. And the discriminant is really the b squared minus 4ac in the formula. And based on what happens with the discriminant, you can tell if you're going to get two real solutions, all right, one real solution, or two complex solutions like we got here. And we kind of talked about them as we went through it, but we'll write it out formally now. So for this definition, the discriminant of a quadratic equation in standard form. When I say standard form, I'm talking the ax squared plus bx plus c equals 0 form. You have to have that form first. It is given by the b squared minus 4ac. It's the part underneath the radical in your quadratic formula, right? So in your quadratic formula, right, you have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. For the discriminant, I'm just talking about this piece here. And the part under the radical is going to tell us about our solution. So, and we talked about it as we did it. So if b squared minus 4ac, all it's saying is if the discriminant, right, the part under the radical, is greater than 0, we then have, right, so we have kind of like what we had in the first problem that I showed in this video. Right, if that's greater than 0, then what do we have? We have two real solutions, right? So two distinct real solutions. So we have two real two distinct real solutions, meaning that they don't repeat, they are individual values. Now, being real doesn't mean that they have to come out to integer values. It could mean that they come out to things that have radicals in them. They just aren't imaginary. So we have two distinct real solutions if the part under discriminant is positive, because if you have a positive root here, you have positive underneath the square root, you know it can't be imaginary, and you know that you're going to have more than one answer, so that's why it's plus or minus. So that's what it's really saying. So two distinct real solutions. If b squared minus 4ac equals 0, kind of like what we saw in the second example here, right, that part b squared minus 4ac, the discriminant came out to 0. You only had one real repeated solution is what we call it. So we have one real repeated solution. It's really one solution, but we say repeated because the plus or minus part. Now sometimes for solutions they might use the word roots or root. Those are used interchangeably as you go forward in math. We'll talk more about that as we go forward. And then if b squared minus 4ac is less than 0, meaning the part under the radical is negative, then it's like what we had in our last example here, where you got complex solutions, right? Because this part being negative under the radical, right, the b squared minus 4ac being negative after you evaluated it, is what allowed us to take out the I, which gave us the imaginary or complex solutions. So we have two distinct complex solutions, or roots. And that's because the fact that the part under the radical is negative. So basically, if you remember, the discriminant means the part under the radical. It's easy to remember. It means b squared minus 4ac. Being greater than 0 tells you you're going to have two real solutions. Being equal to 0 tells you that this is going to just cancel out, so you'll have one solution. And being less than 0 tells you that this will come out to imaginary values because you have a negative under the radical. And that's why you'll have complex solutions. So what we're going to do here in this next part is just determine what kind of solutions we have. So we're not going to evaluate the entire thing for what the solutions are. We just want to determine what type of solutions we have. So let's take a look here. So if I said to determine if each of the following has two distinct real solutions, one real repeated solution, or two distinct complex solutions. All right, so we're just going to determine the types of solutions, not actually find the solutions. So for the first one here, if I wrote 3x squared minus 2x plus 8 equals 0. Now you could go through and use the entire quadratic formula on it. You could also, try other methods. But if I'm just trying to determine this, the real thing I need to use is just what? It's just the discriminant. So even though I don't say use the discriminant here, you should be using the discriminant to find it. Now, if I specifically say use the discriminant, you have to use the discriminant. So discriminant is the b squared minus 4ac. Remember, this has to be in standard form first, which it is. And so the b squared minus 4ac, because that's all you need, is the part that's under the radical from the quadratic formula, the b squared minus 4ac, and we want to see if it comes out positive, negative, or 0. So b squared, well, what's b? b is negative 2, so this will be negative 2 squared, right? That's the middle coefficient there, minus 4 times a is 3, times c, which is 8. And then, we're simplifying this. Negative 2 squared, make sure you have those parentheses there, because a negative squared makes it a positive, so this will be positive 4. Minus 4 times 3 times 8, so it's minus 4 times 3 is 12, times 8 gives us minus 96. And this equals 4 minus 96, which is negative 92. Now the important thing about it is what? Well, it's the sign of it. Is this b squared minus 4ac greater than 0, less than 0, or equal to 0? Well, this is negative, so this is less than 0, so this tells you what? Well, if it's negative under the radical here, that means what kind of solutions are we going to have? We're going to have complex solutions, because it's going to come out to an imaginary if you have a negative under the radical. In other words, we're using this last statement. So this has two distinct complex solutions. And that's what they're asking us to find. What if I said this one here? If I said x squared minus 5x, actually it should say equals 3. So x squared minus 5x equals 3. Well, we're trying to find the nature of the roots, right? Trying to find the types of solutions we have. First thing you want to do is make sure you have standard form. So I'm going to subtract 3 from each side. So I have x squared minus 5x minus 3 equals 0. Because remember, you can't use quadratic formula unless you have standard form. The same thing applies to the discriminant. So we're trying to figure out what kind of solutions we have. So we're going to use the discriminant, the b squared minus 4ac. Well, what's b? b is negative 5, so it's going to be negative 5 squared minus 4 times a, which in this case is 1. If you don't see a value there, remember it's 1, times c, which is negative 3. Remember, just using the coefficients, not the variables. This gives me negative 5 squared, and negative squared makes it positive. 5 squared is 25. Negative times a positive times a negative. Negative and negative makes it a positive. 4 times 1 times 3. It makes that 12. So we got 25 plus 12, which equals 37. Now remember what's important about this. It's either greater than 0, less than 0, or equal to 0. Well, this is greater than 0, right? Discriminant being greater than 0. This is greater than 0 inside the radical. That tells you that you're going to have real number solutions. In other words, it might not be a perfect square, but that's okay. But it's going to be a real number solution. 37 is greater than 0, so we know it's going to be two distinct real solutions. And that's because we're taking the square root of a positive number. Now, you could be more specific. If it doesn't come out to a perfect square, like 37 is not a perfect square, you could call these irrational solutions, because when you take the square root of it, it's not going to come out to a perfect square. If it does come out to a perfect square, let's say it was 36, the square root of 36 is 6. If it's a perfect square, then you could say two distinct rational real solutions. Either way, make sure you understand that it's two real solutions, though. If it's a perfect square, they're rational. If it's a square root you can't take the perfect square of, right, then it's irrational. And let's just look at one more. If I said I had 4x squared minus 4x plus 1 equals 0. So, taking a look at this in the standard form, we're just trying to figure out what types of solutions we're going to have. So I'm going to use the b squared minus 4ac, the discriminant. And b squared is what? Well, negative 4 is what b is, so it's negative 4 squared minus 4a times 4. So minus 4 times a, which is 4, times c, which is 1. Negative 4 squared is a positive 16. Negative 4 times 1, that's going to be minus 4 times 4 is 16, times 1 is 16. 16 minus 16 is 0. The discriminant equals 0. Right, b squared minus 4ac, that does equal 0. That tells you that the part under the radical in your quadratic formula would be 0, which means that that would cancel out and you would just get one answer because it would be just plus or minus 0. And that's what this says down here, right? We have one real repeated solution. So this would be one real repeated solution. So hopefully this was a good review of the quadratic formula and also shows you why you get the type of answers you do. Using the discriminant is important in terms of knowing what types of solutions you'll have. If I specifically ask you to use a discriminant, you have to do it that way to figure out the types of solutions. I don't want to see you do the whole quadratic formula and tell me the answer at the end. That would be doing more work than was necessary for the problem.